All right, in this video, we'll be covering TI-89 techniques from chapters 7 through 10. Actually, chapter 7, there's nothing new in the calculator. It was mostly normal calculations, which we've already seen. So I'll be focusing on techniques that correspond to chapters 8, 9, and 10, which is mainly confidence intervals and significance tests. But let's start with F5. I want to point out, and we've been in here before with normal CDF and inverse normal, but I want to point out that you've got CDF and inverse functions for other important distributions as well. There is a T-CDF, chi-square CDF. Scroll down a bit further, there's a binomial CDF and a geometric CDF. All of those may potentially be useful to you. They're pretty easy to figure out. Geometric CDF, put in a probability of success, a lower and an upper value. It's inclusive. It'll run that for you. Let me get back in there. Binomial is pretty similar. I don't necessarily need to show you that. You can look at it on your own. Chi-square and T-CDF, they will require degrees of freedom, no surprise there, but otherwise they work the same way as the normal CDF, put in an upper and a lower value. And upon hitting enter, it'll give you the area or proportion of a distribution between the cutoffs that you put in. Inverse, similar. T and chi-square behaves the same way as inverse normal, where this area input is an area below a known location. Well, I shouldn't say known location because we're going to find the location, but the area below a location of interest here, I want to know what's the actual chi-square value if I have 10 degrees of freedom such that 25% of the area is below. If I hit enter, it gives us back a 6.7. So that would be the chi-square value. All right, so a lot of options to play with there. I've seen these be really useful on certain multiple choice questions on the AP test. So it's worth playing around with there and at least knowing what options you have. Moving over to F6 tests, as in significance tests. You have several options in here. A lot of them correspond to things we've done in this course. The first is a z-test. If you hit enter there, it will ask you data or stats. And I'm hitting arrow keys to open up that menu and make the selection. So here's the distinction. Data means you have actual lists of raw data in your calculator already inputted that you would like to use to run a procedure. If I hit data here, calculator wants to know what list I'm looking at. So frequency should be left open, but whatever list I want to do a z-test on, I put in list 1. We also need a null hypothesis. I think my list 1 is just some numbers from 0 to 5. So let's say we had a hypothesis that the real mean is 2. Standard deviation. You'd have to know a population standard deviation to input. I'm just making up numbers here. And then alternate hypothesis, you need to decide, is it a greater than, less than, or just not equal to. All right, and it gives you some useful stuff, right? It's got the z statistic, it's got your p-value, it's got sample standard deviation. Now, having said all that, you are very rarely, if ever, going to use a z-test for a mean, because in our class, we don't have a population standard deviation in most cases. You saw that I had to input one there, I just kind of made something up, but in reality, when you're running a significance test for means, you should always be doing a t-test. This is the one that you want to look at. If I have data already, again, just put in the null hypothesis, put in what list you want, set your alternate hypothesis, hit enter, it'll give you back a t statistic, it'll show you your p-value, it has degrees of freedom in there. So it's really straightforward to use these. If I go in again, let's suppose I have a prompt where I don't have a list of data, I just have a sample mean, sample standard deviation given. I can go to t-test and choose stats. And now it's not going to ask me what list I want because there is no list. I just have to be ready to plug in some values from a prompt. I should have a null hypothesis, a sample X bar, a sample standard deviation, a sample size. And then I get back, again, a t statistic, a p-value. You still have to show work for all this stuff the same way we've done throughout the chapters, but as far as the calculations, this is a quick way to get those values. All right, most of these procedures behave similarly, but let's take yet another look to see what else we have here. Two sample Z, again, you would rarely use this because for two sample mean analysis, we're usually going to use a t-distribution. If we want to run a test on the difference between two populations, we're going to go with this one. And it's going to ask you for an X bar and standard deviation from each of two populations, of course, and it'll eventually calculate your p-value. Make sure you set in the right alternate hypothesis for these procedures. One proportion and two proportion Z. These you will be using. We first learned about a one proportion Z test in chapter 9, two proportion Z test in chapter 10. Let's open up one of these and see. One proportion Z. You're going to have to input in this first cell a null hypothesis about a proportion. The next two cells are where you are inputting information about your sample. What was your sample size? How many quote unquote successes did you have? I think a proportion possibly is 0.1. Go with 1 out of 6. Two-sided. I'm just making up some values here just to show you what you get back. It shows you a Z statistic, p-value, sample proportion p hat. All right, so everything that you need pops up pretty quickly. I'm going to make a different video to cover chi-square because those are a little more complicated. So we'll come back to that one next time. F7 confidence intervals. Again, this will behave fairly similar to the ones we've already seen. Z interval, not super common. T interval for means, you'll use that quite a bit. Two sample T you'll use, probably not. Two sample Z. And then one proportion Z, two proportion Z are pretty common as well. These are all very straightforward. You're choosing data or stats again when you pick these procedures. If you choose stats, be prepared to input an X bar, sample standard deviation, confidence level now, in addition to sample size. And it's going to give you back margin of error is kind of nice. The one thing it doesn't give you, which is a little surprising to me, is it doesn't give you back a critical value, which you're going to need for your work. Okay, so when you write out your formula for the standard deviation, it's the value that we multiply to get the margin of error. So just to show you really quickly how you would do that. What level did I just type in there? Let's take another peek in there. It's the wrong one. Try this one more time. So I've been going for a 99% interval. If I want to find my actual T critical value, what I'm going to do, I'm going to go back to F5. Whoops, F5, inverse T. Okay, now I'd have to retain whatever degrees of freedom I had before. I don't remember what I had typed in before, but you have to put in the degrees of freedom. For a 99% interval, you have to do your little calculation of what's the area below that particular interval. What's the area below the 99%? So we know we have 1% on the outsides, but we're cutting that in half. So if I type in a 0.05 as an area below an interior region of 99% with actually that's not even right, is that? It's 0.005. You need to take a 0.01 and cut it in half. So you are going to be using inverse T, possibly inverse normal when you run these, when you show your work for confidence intervals. Okay, Okay, so this value here would show up in your formula as a t. So yeah, t interval, 2 sample t, 1 prop z, 2 prop z. Those are the ones that are useful. Lin reg t, we already saw this in our in one of my videos for chapter 12. Where you're putting in both lists, calculating an interval for slope, storing your equation. So we've seen that before as well. Play around with these. Let me know if you have questions. Come to academic support. There's a lot more than what I was able to show in this short video. It'd be a little tedious for me to show every single procedure all the way through with an example, but play around. Let me know if you get stuck. All right. That's all. Thanks for watching.